A TV manufacturer knows that their TVs have a normally distributed lifespan with a mean of 8.5 years and a standard deviation of 0.8 years. If a TV is picked at random 6% of the time, its life will be less than how many years? So we're looking here for an X value. We're going to give our answer to one decimal place. Let's draw a quick picture here. We've got a normal distribution, so we've got our little bell curve. And our peak happens at 8.5, okay? And we want to know 6% of the time its life will be less than how many years? So we're looking for something where it's 6% to the left. Okay, that's pretty small. So something over here, and we're looking for this number to be 0.06. Okay. Now, we know the proportion. That means we know the entry in the table. So let's go to our table, and we're looking for something close to 0.06. All right, and it looks like right here we've got those two numbers that are really close to 0.06. We know 0.06 is between those. And so we look at the corresponding z-scores. That would be negative 1.55 and negative 1.56. And we're just going to pick the average of those for our z-score. So z equals negative 1.555. Okay, that's halfway between negative 1.55 and negative 1.56. That's our z-score. And we know that z-scores, z is equal to x minus the mean, which is 8.5, divided by the standard deviation, which is 0.8. And now we just need to solve for x. So we'll multiply both sides by 0.8. So negative 1.555 times 0.8 equals x minus 8.9. And then we can add 8.9 to both sides. So 8.9 minus 1.555 times 0.8 is equal to x. So let's go ahead and plug that into our calculator. 8.9 minus 1.555 times 0.8. And we get 7.656. 0.656. And that's our x value, and we want to round to one decimal place. And so that's actually going to be 7.7. And that's, of course, in years.